Hi everyone. So in this video we are going to study about feedback amplifiers. So before studying the feedback amplifiers or feedback topologies, we need to get some basics of op-amp. So we have already seen some basics of op-amp. Now I will just add 1 or 2 points. So in the previous video when we studied differential amplifier with active load, we studied about the basics of op-amp. So just adding up 1 or 2 points. So we have already seen the internal structure. What is the internal structure? This is the op-amp, right? This is the op-amp that we are going with. So you already know this is the internal structure, right? So I don't need to make that op-amp sign, right? So what will be your V naught? V naught is A into V1 minus V2. That also you know, right? So for an ideal op-amp, Rin is infinity. I told you, you need as high impedance, right? As high impedance as you can get. So Rin should be infinity. If Rin is infinity, then tell me what will be the input current? If Rin is infinity, there is zero current flowing, right? Just a second. Yeah, there would be zero current flowing, so I in would be 0. This is the case for ideal op-amp, right? What I told you about R naught should be as low as possible so that maximum voltage reaches at the output. So R naught should be 0. What about AV? AV should be as high as possible, right? AV, here I should have written AV into VD. AV into VD. What about AV? AV should be as high as possible because you want maximum gain. So for an ideal op-amp, AV is infinity. Well and good, this much is clear. Now there will be two more things coming. So these things are CMRR and slew rate. You don't know about these things, right? We will discuss about these things when we study op-amp. Now we are not studying op-amp for now. For now we are studying feedback amplifiers. So these things you don't know. So forget about these two things, but at least remember these things. What are the things? Rin should be infinity. Current should be 0. R out should be 0 and gain should be as high as possible. Well and good. So this much of things you need to remember. So what else I told you? If V positive increases, what is this V positive? V positive is equals to, this is V1. If V positive increases, then what will happen? Your V out will increase, right? And if your V negative, that is V2, if that increases, then your output would decrease. Well and good, very easy thing. Now one more thing I will tell you about this op-amp. So let's take an example for that. Let's just say our op-amp gain is 10 to the power 3. The op-amp that is given, the gain is 10 to the power 3 because this is not ideal. The op-amp is not ideal and it has some saturation voltage. So whenever you see an op-amp, there will be some saturation voltage written. Plus Vset and minus Vset. What are these saturation voltage? So when we designed the op-amp, what did we do? There was a differential amplifier, there was an active load, all those things was there, right? There was differential amplifier there. So what was happening there is, there was a supply VDD, right? There was a supply VDD and at the lower side I made ground, but in actual we don't keep it ground. In actual we keep it minus VSS. In actual we keep it minus VSS and this supply should be VDD, or you can say minus VDD. Like let's just assume if I am putting plus 5 here, then I would put minus 5. I will not put 0. Where I made the ground, instead of that ground we put negative potential, plus 5 and minus 5. What is the reason behind that? I will explain you in some other YouTube lecture. It would take me around 15 to 20 minutes. So that is not relevant to your examination or even for the interviews. So I will explain you one day. You can comment down. I will certainly explain you why it should be negative, not 0. I will certainly explain you. I will just give you a hint. Like I told you, at the bottom we need to use current source. And this current source we can make from a MOS, right? So try thinking about it. What should be the potential of the source? In a MOS, what should be the potential of the source to keep it in saturation region? Well, the source potential will not, the saturation region will not depend on the source potential, but for an ideal operation, what should be the potential of source? It should be as low as possible, right? It should be as low as possible. So what should be as low as possible? That is minus VDD. So this is the reason I am giving you a hint. You can think more about it. In some video, I will certainly explain you. Okay, but this is not relevant to this examination. So I just wanted to tell you there will be two supplies given for the MOS, plus Vset and minus Vset. So these are the saturation voltage. It can be any value. So here we are assuming those saturation voltage to be plus minus 5 volt. Now there is one thing about the op-amp, that is your output can never go above saturation voltage. Your output can never go above saturation voltage. This note I am going to write. This is a very important point for an op-amp. Output can never go above saturation voltage. The maximum output you can have is that saturation voltage only. You cannot have more than plus Vset output or minus Vset, or you cannot have below minus Vset as well. And your op-amp can never go above positive saturation voltage and can never go below, can never go below saturation voltage, negative saturation voltage. So maximum value of the op-amp output is plus Vset and minimum value is minus Vset. Output will remain between plus Vset to minus Vset only, right? So basically, what is your op-amp output? Op-amp output is V0 into AVD, I can say, right? Differential voltage, V0 into AVD, V0 into AVD. So what will be your VD? Or I can write, what is the range of V0? It would be above minus Vset. Range of V0 is above minus Vset and below plus Vset. So minus Vset, what is V0? V0 is A VD and plus Vset. So your VD value will always be between minus Vset by A to plus Vset by A. This is one of the fact that you can remember. You just don't need to mug it up, just a very simple fact that your output will always be between plus Vset to minus Vset. That's it. Well and good. So very easy thing. Now we will understand one thing like that. Our let's just assume our gain is 10 to the power 3 volt per volt and our saturation voltage is 5 volt. Now if our differential voltage is 1 millivolt, what will be your output? Output will be A into VD. A into VD. What is A? That is 10 to the power 3. What is your VD? That is 1 millivolt. What will be output? 1 volt. Considerable. It is not higher than 5 or lesser than minus 5. So it is considerable. Let's talk about minus 3. So what will be your gain? Minus 3 millivolt. Not the gain. What will be your output? Minus 3 millivolt into the gain. What will be your output? Minus 3 volt. This is also considerable. What about minus 5? Minus 5 millivolt into the gain. What is the output? Minus 5 volt. This is also considerable. Why so? Because I told you the minimum value can be minus 5. Here in this case, tell me 7 millivolt into 10 to the power 3. What is the output you are getting? 7 volt. This is wrong. Why so? Because maximum is plus 5 volt. So the op-amp will try to go to 7, but it will pull it down to 5 volt. So your final answer would be 5 volt. This is your correct answer. The op-amp is trying to go to 7 volt, but it is pulling down to 5 volt. Are you getting this point or not? Right? If your VD is minus 6 millivolt, what will be your output? Your minus 6 millivolt. Minus 6 millivolt into the gain. So your output would be minus 6 volt. But no, this is not correct. Your output would be minus 5 volt only. Your output was trying to go down to minus 6, but it pulled you to minus 5. It cannot go above, it cannot go below. So this is the property of an op-amp. So what will be the characteristics of the op-amp? Can you draw the characteristics now? I am drawing V0 versus Vin graph. Not V0 versus Vin, I am drawing V0 versus VD graph. V0 versus VD graph. This is your V0 and this is your VD. What was VD? VD was V1, V positive minus V negative. V positive minus V negative, right? So V0 versus VD. What is the typical value of V0 by VD? That is A only. A. V0 by VD. What is the typical value of V0 by VD? That is A. V0 was AVD. So what will be V0 by VD? That would be A. So this slope is A. This slope is A. Now if you keep on increasing the VD voltage, what will happen? Your output will keep on increasing. But your output cannot keep on increasing. It will saturate at some point. That is saturation voltage, plus saturation voltage. And when your output is going down, it cannot keep on going down, it will saturate at some point. That will be minus Vset voltage. Say yes or no. So this will be your plus Vset, this will be your plus Vset, and this will be your minus Vset, right? And at what voltage it will be happening? What will be that voltage? What will be this voltage? So now let's just remove it off. This angle was theta, so basically your tan theta is A only. So the slope shows the gain. What will be this potential? Tell me, what will be this potential? At what value of VD your output will be saturated? So at what value of VD your output will be saturated? So what is your output? Output is plus Vset. So at plus Vset by A, your output will be saturated. At plus Vset by A. And this potential will be minus Vset by A. Right? In the previous question, what was your saturation voltage? 5 volt. What was your gain? 10 to the power 3. So after 5 millivolt, you will always get plus Vset only. And below minus 5 millivolt, you will always get minus Vset only. So this is the property, very easy thing. I hope you have understood that op-amp output can go above till a certain voltage only and go below till a certain voltage only. And in between, it will stay in linear region. So we call this region as linear region. From here to here, this is the linear region. Linear region. And after that, here you reach the saturation. Here you reach the saturation. This is the saturation. Well and good. No doubt about it. So I will repeat it once again. The op-amp shows the linear characteristics only, but to a certain voltage. Your output cannot go above a certain voltage. If it is going above a certain voltage, your op-amp will pull it down and it will saturate it to plus Vset. And if it's trying to go below a certain voltage, your op-amp will pull it up and it will saturate it to minus Vset. Right? And in between, it will behave linearly. It will give you a gain of A. Let's just say your saturation voltage is plus 5 and minus 5. What does that mean? That means that your output can go from minus 5 to plus 5. It can take any value from minus 5 to plus 5, but it cannot take plus 6, it cannot take minus 6, it cannot even take plus 5.1, it cannot even take plus 5.001, it cannot even take minus 5.001. It can take only between minus 5 to plus 5. That's it. Well and good. Understood? I will just make one more graph and it will make it all clear for you. Let's just say this is a line. This point is minus Vset and this point is plus Vset. So in this range only your op-amp output will lie. This is the range where your output of op-amp will lie. Op-amp output. Op-amp output. That's it. So this was the basic of op-amp that was needed. Well and good, everything is crystal clear. So when we study op-amp, we will study once again about it. Within 5 to 10 minutes, I will be clearing all these things because you have already studied it. So within 5 to 10 minutes, I will be clearing all these things that this thing is that, this thing is that. In case of op-amp, when we are going to study again. But here we are studying it deeply, that what is the characteristics, why this characteristic is there. Now there are a lot more things about op-amp. There are a lot more things that you need to learn about the op-amp, but that we will learn when we study specifically op-amp. Now we are going to study feedback amplifier. In feedback amplifier, sometimes you will see op-amp circuits. Sometimes you will see op-amp coming into the action. So that's why I taught you this concept. Now with this concept, you will be able to proceed in the feedback amplifiers. So let's just understand what is feedback. What do you mean by feedback? Forget about this definition. Tell me what is a feedback. Let's just assume I am teaching you something, right? I am teaching you something. So you are understanding that thing. So you are receiving some output from my side, right? What you are giving to me, you are giving your time. You are watching this lecture, you are giving your time. And then you are watching this lecture and you are receiving some output from me. Now based on the output, what you can do, you can give me some feedback. That sir, you are teaching slowly or you are teaching fastly, you are teaching nicely or you are not teaching that good, that thing, right? So based on the output that you are receiving, you can give me the feedback to back into me, and now based on that feedback, I can work and improve my output. there was some input, there was some output, I received some feedback. Based on that feedback, I will take it back to input and I will improve my output and I will give you a better output or worse output. Let's just say you are giving me so much of positive feedback that sir, you are teaching great this or that thing, and then I just worsen my concept, that I just teach very badly. This can happen too, but this is not going to happen. So don't give negative feedback or positive feedback, or stop giving any kind of feedback. Don't do this thing. This is just an example. So just I will tell you. So just I am telling you that based on the output that you are giving, using that output I can improve my output or I can worsen my output. So this is what feedback is called. So what is the definition written here? Taking a fraction of the output of an amplifier and connecting it back to the input, and this feedback signal can be connected in a way that either it is adding up with the input or it is getting subtracted. Understood? This is the definition. Let's see it with an example. You will be able to understand. So there are two kinds of feedback: negative feedback and positive feedback. Because you will be getting some output, then it is being fed back to the input. Now it can be added as well or it can be subtracted as well. So first we will study positive feedback. So let's see this. So before that, let's make a system without any feedback. System without any feedback. So this is a very simple system that you are having a gain A. This is a system of a lot of online institutes, that there will be some only input and there will be some output. There is no feedback. Just a joke it is. So basically there is input and there is output. There is no feedback. So system without the feedback. Now we are going to introduce positive feedback. So what is happening in positive feedback? So this was your input was coming and you are receiving some output. Now what is happening? Some portion of output is going into some feedback factor. This term is known as feedback factor. Feedback factor. So you are not directly giving the output. You are multiplying that output with the particular value. It can be any value. It can be 1 by 2, it can be 3, it can be 4, it can be 5, it can be 7, it can be 100. So you are multiplying that output with a particular value and giving it back to the input. Now since it is positive feedback, that's why this value will be added. Your output is coming, it is being fed to the input, and your output is not directly coming, it is getting multiplied with some value. This beta can be 1 as well, that your output is directly coming. Beta can be half as well, so your output is getting multiplied with half. It can be function of something as well. It can be function of temperature as well. So you are giving the output towards the input with some multiplication of some factor, that is known as feedback factor. And this gain A is known as open loop gain. So better I write here only. This gain A is known as open loop gain. Why open loop? Because the loop is open. There is no loop. So this is known as open loop gain. This is open loop gain. Since there is no loop, that's why we call it open loop gain. Right? So this beta term is known as feedback factor. So this is being fed to the input. Now what you will receive here at this portion, what you will receive here, you are going to receive V in plus beta V naught, right? V in is coming from here and beta V naught is coming from here. So here you are receiving V in plus beta V naught. Now this V in plus beta V naught, this is going to be multiplied with A and you will receive your final output V naught. From V naught, beta factor is being multiplied, beta V naught, V in plus beta V naught, that is being multiplied with A and you are receiving your final output. Here what was happening? Here your V naught was simply equals to A into V. But here what is your V naught? Your V naught is A into V in plus beta V naught. Your V naught is A into V in plus beta V naught. So now it would be V naught minus A beta V naught equals to A V in. So V naught by V in would be A upon 1 minus A beta. This is known as closed loop gain. Closed loop gain. So you derived this expression A upon 1 minus A beta. So there was some input. It was directly going towards the output with the gain A. So you are getting A V naught. But this is not the case now. your output is being fed to the input with a multiplication of feedback factor, that is beta. So V in plus beta V naught, this is what your amplifier is seeing. This is what your open loop gain is seeing now. So your open loop gain can see V in plus beta V naught, that will be multiplied with A, and you will receive your output that is equals to V naught. So your V naught by V in is A upon 1 minus A beta, and that is known as closed loop gain. So this is the new gain that you have received, right? So this is what is known as positive feedback. Now we will see very interesting thing in positive feedback. Let's just assume by some factor, by any factor, let's say by any factor, your temperature, your output increases a bit. This is, we are talking about positive feedback. By any factor, it can be temperature as well, it can be pressure, it can be anything. The output of your system is increasing just by a small margin. Then what will happen in positive feedback? If this increases, then this value will certainly increase. If this value increases, then what will happen? This value will certainly increase. And if this value is increasing, then this value is simply getting multiplied with this, so this value will further increase, right? And if this is further increasing, then it will go into the loop again and it will increase again, right? If it increases by a small margin, increases, then increases, this increases, then output increases. So your output will keep on increasing. Let's just say your output was something like this, and if it increases by a small margin, now it will keep on increasing. So your output will become unstable. So in positive feedback, your output is unstable. So if in positive feedback, if output increases, then it keeps on increasing, and results in unstable output. So positive feedback system are unstable. Positive feedback system are unstable. Positive feedback system are unstable. You will study more about feedback more deeply in control systems. When you study control systems, you will study more about that. But whatever that is required for analog electronics, that I am going to teach here. Now this I showed for increasing. What if it was decreasing? What if your output was decreasing? If your output was decreasing, then what would have happened? This value would decrease. If this value decreases, then what will happen? This value will decrease. Because V in is constant, beta V naught is decreasing. So this value is decreasing. Then what will happen? This value will further decrease. If this decreases, this again decreases, then again decreases. It will keep on decreasing like this. So either it will keep on increasing or either it will keep on decreasing. So it will eventually give you unstable output. So this is the way of determining positive feedback. And also you got to know that positive feedback are unstable. Positive feedback system are unstable. So whenever you see a circuit and you are asked whether the circuit is in positive feedback or negative feedback, so what you will do? You will first increase the output. Then you will walk around the loop and you will see what is happening with the output. Is it getting increases or it is getting decreased? Based on that, you can tell which feedback is that. If your output is increasing and then you walk back into the loop and again it is increasing, that means it is positive feedback. Let's talk about negative feedback, then we will understand it more. So what is happening in the negative feedback? The same thing is happening. Output V naught is being multiplied with the feedback factor and now it is being subtracted. Now it is being subtracted here. So output is multiplied with the feedback factor beta and it will be subtracted with the input. Previously it was getting added. Since this is negative feedback, so it is being subtracted. So this is V in minus beta V naught. V in minus beta V naught. And that will be multiplied with the gain A and you will receive your output. So V in minus beta V naught will be multiplied with gain A and that will be your output. If you solve it, V naught by V in, you can solve it on your own. What you will get? A upon 1 plus A beta. A upon 1 plus A beta. So this is the closed loop gain of negative feedback. Closed loop gain of negative feedback. Now check what happens in the negative feedback if your output increases. So if your output increases, then what will happen? This value will increase. If this value increases, then this value will decrease, right? This particular value will decrease. If this value increases, then this particular value will decrease, right? Because beta V naught is increasing, so something getting subtracted from V in, and getting subtracted value is increasing. That means the complete value is decreasing. So this value is decreasing, then further your output is decreases. Your output decreases. So first we tried to increase it, but your output decreased. Now if your output is decreasing, then what happens in the circuit? If this decreases, that means this value will decrease. Now if this value is decreasing, this particular value is decreasing, that means the overall value will increase, because that is getting subtracted, this value is getting subtracted, so overall value will increase. Now if this value increases, then this is simply getting multiplied with gain A, so it will increase. Now if it is again increasing, then again decreasing. So here your output is not going stable. Sorry, here your output is not being unstable. If it increases, then there is something that is pulling it down, then there is something that is pulling it up, then something pulling it down, something pulling it up, pulling it down. So there is a stability maintained. So basically, if your output was going to try to go up, then something was pulling it down, then something is pulling it up, pulling it down, pulling it up. So that's why it always remains stable. It's not that it will reach to some undefined value or it will go down only. It will keep on going down. It's not like that. It will be stable at some point, right? So in negative feedback, your output is stable. So in negative feedback, you get a stable output. So what is the way of determining a negative feedback? Whenever you see a circuit, what you will do? You will first try to increase the output. Then you will walk around the loop, and if you see the output is getting decreased, that means it is working in negative feedback, right? Otherwise it is working in positive feedback. Let's see an example if there is some example. So I will pick some example of op-amp only. Okay, let's see an example of op-amp. Very easy example and it is highly used. This is your V. So when you are checking the type of feedback, you don't need to worry about input. When you are checking the type of feedback, you don't need to worry about input. You can short it up. You can short it. You don't need to worry about input. So when you check the type of feedback, I will write it down. When you check the type of feedback then at that time nullify the input. Nullify the input. If current source is there, that will be open circuited. If voltage source is there, that will be shorted. Then nullify the input. Now tell me, which feedback is that? What is the method? We will try to increase the output. If this output increases, then what will happen? By voltage division, you can see, since there is 0 ampere current here, since there is 0 ampere current in the MOSFET, sorry, not in the MOSFET, in the op-amp. In the op-amp, there is 0 ampere current. I told you, what is the input current of op-amp? Input current of op-amp is 0. This current is always 0 ampere. Okay, this is the property of an ideal op-amp. This current is always 0 ampere. So input current is always 0 ampere. So now what will happen? So if this V naught increases, then what will happen? This node will increase by potential divider, because V in is already shorted. By potential divider, this node will increase. Now if this node increases, then what will be your output? Your output is A into V positive node minus V negative node. V positive node is 0, that doesn't matter. V negative node is increasing. If V negative node increases, that means output will decrease. And if this node decreases, then what will happen? This node will decrease. If your negative node is decreasing, that means your output will increase. So there is a stability, increasing, decreasing, increasing, decreasing. So you just need to check one step only. If you increase the output, it is getting decreased. So here only you can determine it is negative feedback. Say yes or no. Negative feedback. So this was actually a very easy example because people directly see that okay, this is negative, so this has to be negative feedback because there is negative feedback connected. So yeah, sometimes people directly see it, but this is not a correct way. I will tell you a lot of example where this method fails. So that we will see, but later on we will see all those examples, right? So let's take the second example. This was the first one. Let's take the second example. It's not that always when there is negative sign and then there is feedback connected, like this is the feedback connected. Yeah, how did you tell this is a feedback? Because some part of output is going back to the input. Some part of output is going back to the input. That's why it is known as feedback. This was the open loop. This was the open loop. Now some part of output is going back to the input. So this is feedback. Understand? Understood? Now take the second example. What we are going to do? We are going to copy the same circuit only. Just negative sign will be replaced with positive sign. And then you can tell what kind of feedback is that. Right? You can certainly tell it. So if this voltage increases, then what will happen? Input is already shorted. This voltage increases, then this voltage will increase. What is your output? Output is A into V positive minus V negative. So if this voltage is increasing, that means this voltage will certainly increase. If this increases, it will keep on increasing. So that's why it is positive feedback. Right? So this was the example of negative and positive feedbacks. There can be more examples. In the complete chapter, we are going to study this thing only. And in the op-amp, we are going to focus on this thing again and again. That what kind of feedback is that? How do you determine the kind of feedback? So we are going to see this very, very deeply. And this is not taught like by most of the educator I have seen. This is not taught. Right? How you determine the kind of feedback. They just see that this is a positive sign, so this is a positive feedback. But this is not the case. We will tell. I will tell you about it, but in the op-amp chapter. Okay, so let's move on to the advantage of feedback. Now we are going to see the advantage, but we will only see the advantage in negative feedback only. Why is it so? Because negative feedback system is stable. So now we are going to not discuss about positive feedback. We will come back to positive feedback when we study op-amp. But here we are going to study about only negative feedback. Why is it so? Because negative feedback systems are stable, and as a designer, we always need to make a stable system. It's not that I am making a regulator, and if you just increase the speed of regulator, the speed will keep on increasing. From 1, 2, 3, 4, 5, 6, 7, 8, the fan will start moving on very quickly. You don't want that. You want a steady state. You want a stable system. So that's why we always study about negative feedback system. Well and good. So now we are going to see the advantage. So first advantage is gain stability. The feedback always provides us gain stability. What do you mean by that? Let's see it. So this is in the open loop, right? This is in the open loop. So there is some input V in and you get some output. So your output would be A into B. Now this is a gain A. So what was our gain A when we designed an op-amp? I'm just taking an example of op-amp. That was some GM R node something, whatever it was. Let's just take this is an common source amplifier only. So what was the gain? GM R node. I told you this GM can depend on temperature. If you remember it, GM is a function of temperature. Now your gain A is also a function of temperature. So now your gain A can change, right? Your gain A is variable. It can change with respect to temperature or any other condition. Not just temperature, there is any other condition in the circuit, the gain A can change. It can change with respect to supply or anything. So if gain A is variable, so let's assume your gain A is variable from, sometimes it gives you a gain of 10 to the power 3 and sometimes it gives you a gain of 10 to the power 4. So it can change to 10 times, 10 to the power 3 to 10 to the power 4. And let's say let your Vin is equals to 1 millivolt. Your Vin is equals to 1 millivolt. So what is the output you are going to expect? output will be A into V in. So if your V in is equals to 1 millivolt, so what is the range of output? Sometimes you will get 1 volt output and sometimes you will get 10 volt output. So if it is there, if there is 10 times change in the gain, that means there will be 10 times change in the output as well. You applied the same input. You applied the same input 1 millivolt. But if there was 10 times change in the gain, your output was also changing by 10 times. Look, you don't know what is happening into this box. You have this black box only. So now you are giving 1 millivolt. One day you check, you are getting 1 volt output. Okay. You go to your manager and say that, sir, I am getting 1 volt output. Now other day your manager is coming with you and he asks you, show me what you are getting as the output. So you apply 1 millivolt and it is giving you 10 volt output. And the next day you get fired, right? You lose your job. Or if you are a student, your degree is in danger now, right? So the gain is not stable here, right? So now we need a stable gain. So what we can do? We can provide it a negative feedback. So if you provide a negative feedback, so what is the negative feedback? This is a negative feedback. So your V in was there, it was in open loop, so you are simply getting some output. Now you are taking the output, multiplying it with the factor of beta. You are getting some beta V naught here, and you are subtracting it with the input. And now this is being fed to the gain A, that is V in minus beta V naught. So V in minus beta V naught into A is equals to V naught. So your V naught would be A into V in minus beta V naught. V naught would be V naught by V in, you already know, that would be A upon 1 plus A beta. Now let's just say your A is very large. Your A was 10 to the power 3. Your A was 10 to the power 3. So I designed my beta factor such that beta is in my hands. Beta is in the hand of mine. Your gain A, you don't know, that is 10 to the power 3 or 10 to the power 4. It can be anything. It can be variable. But beta is in my hand. So I will design my beta such that your A beta is very, very greater than 1. So beta is designed such that A beta is very, very greater than 1. A beta is very, very greater than 1. So what you can write as V naught by V? If A beta is very, very greater than 1, you can ignore this A. So that would be A by A beta. Nearly, because you are assuming it to be very, very greater than 1. So nearly it would be A by A beta. So the gain would be nearly equals to 1 by beta. So the gain you are getting is nearly equals to 1 by beta, and beta is constant because you will design this beta and that would be constant. So here you are getting a constant gain. Now what you will say, sir, this is good, you did this thing, but previously I was getting gain A equals to 10 to the power 3. Now let's just say I designed my beta such that it is 1 by 2. So what will be my gain? Gain is 2. So sir, gain is reduced. Yeah, the gain is reduced. This is for sure. The gain has reduced, but you got the stability. So if you are getting the gain stability, you have to compromise with the amplitude of the gain. Previously the amplitude was 10 to the power 3, but now the amplitude is 2 only. So yeah, the gain amplitude is reduced, but you have achieved the stability. So based on the requirement of your system, based on the requirement of your chip, you will do this thing. If you require a higher gain but not the stability, then you will not apply any feedback. But if you need a lesser gain but the stability, then you will apply the feedback. And in 99% of the systems, you always need the stability, so you always apply the feedback. Okay, well and good. So here you are getting the finite gain, constant gain. So is there any example? Yeah, there is an example. So this was our op-amp. So what will be your output here? V naught will simply be AV in, right? And V naught will simply be AV in. If A is variable, then V naught will also be variable. and this is not what you want. So what you will do, you will take some factor of output. You will take some factor of output. What you need beta V naught. So you need some factor of output. So what you can do, you can make a voltage divider, right? R1 by R2. So what is the voltage you are getting here at this point? That is V naught into R2 by R1 plus R2. So this is the voltage you are getting here. I can call this voltage as beta V naught. Now this voltage, you are feeding it back towards the input. You are feeding this voltage back to the input. You got some voltage and you fed it back to the input. So you fed this voltage back to the input here, beta V naught. Did you understand? First it was in open loop, V in, V naught. You took some portion of output and you fed it back to the input. Now what will be your output? V in minus beta V naught, V positive minus V negative into A is equals to V naught. So V naught by V in you get is A upon 1 plus A beta. And generally for op-amp, A is very large. So what is the approximation you will get? V naught generally for op-amp is A is very large. So what is your final output? That is 1 by beta. So what was your beta here in this case? Beta was, what was your beta? I told this as beta V naught. So what was your beta? R2 upon R1 plus R2. So what will be the reciprocal of this? What will be the reciprocal? It will be 1 plus R2 by R1. You can take the reciprocal. What will be the reciprocal? R2 plus R1 upon R2. So sorry, it would be 1 plus R1 by R2. Sorry. 1 plus R1 by R2. 1 plus R1 by R2. The resistor that is there in the feedback divided by this resistance. 1 plus R1 by R2. So this is the gain you are getting, and resistance value are generally constant. So this is the constant gain you are getting. So here, even if A is variable, even if your A is variable, your V naught is constant, that is 1 plus R1 by R2. So your V naught you are going to get is 1 plus the gain is constant, that is 1 plus R1 by R2. Now if you put, let's just say if your R1 is 1 and R2 is also 1, so what will be the gain? Gain will be 2. So if you put V in equals to 1 volt, you will get 2 millivolt. If you put V in equals to 2 volt, you will get 4 millivolt. If you put V in equals to 3 volt, you will get 6 millivolt. But in this case, if A is variable, you can get any output, and any day you can lose your job, you can lose your degree. But here you will not lose your job, because you know that to the manager or to the supervisor, you can tell that, sir, my gain would be 1 plus R1 by R2, and that is for sure. I have achieved the gain stability by applying the negative feedback. Say yes or no. So this was the first thing. Now based on this, we can see a numerical example as well. I guess, yeah. So there is a numerical example as well. An amplifier is connected in negative feedback. If the percentage change in open loop gain is 10%, then what will be the percentage change in closed loop gain? The loop gain is 99. What is loop gain? I forgot to tell. What is loop gain? So let's just see it very shortly. What was loop gain? We will discuss it about again. So what was the gain we were getting when we had the feedback? Okay, forget about it. What was the gain without feedback? Gain without feedback. That was A, right? Gain without feedback. Now what was the gain with feedback? With the negative feedback. I will say with negative feedback. That was A upon 1 minus A beta. What we were calling this one? This was open loop gain, right? And I was calling this as a whole as closed loop gain. Now this A beta is known as loop gain. A beta is known as loop gain. This A beta is loop gain, because let's see the circuit previously. So from here to here, whatever the gain is there, that is A beta. So A beta is known as loop gain. So here what is the loop gain? Loop gain is A beta, right? This is the loop you are having. So in this loop, what is the gain? A into beta. So loop gain is A beta, right? In the previous example as well, we have seen the loop gain, that is A beta. So that is the loop gain, right? So we will see how to find the loop gain, but later on in this lecture only. But for now, let's solve this example because you need the loop gain value here. So loop gain given is 99. So what they are saying, an amplifier is connected in negative feedback if the percentage change in open loop gain, percentage change in open loop gain. So what is the closed loop gain? Then they are asking what will be the percentage change in closed loop gain. So what is closed loop gain? Closed loop gain. Let's call it ACL. ACL would be open loop gain divided by 1 plus open loop gain into beta. Say yes or no. Closed loop gain is open loop gain divided by 1 plus open loop gain into beta. Now what is given? Percentage change in open loop gain is 10%. So delta open loop divided by open loop gain into 100%, that is equals to 10%. Say yes or no. Right? So what will be the value of delta AOL divided by delta A? That is 0.1. So what they mean to say is that the change in open loop gain. So let's just say your open loop gain was 10. So sometimes it can be plus 11 or sometimes it can be 9 as well, because what is the 1% of 10? That is 1. So the gain can be 11 as well, it can be 9 as well. Let's just say your open loop gain is 1000. So what is 1% of 1000? That is 100. So sometimes it can be 1100 and sometimes it can be 900. So this is what they mean to say, that the change is 10%, plus minus 10%, it can be anything. Right? So delta AOL by AOL would be 0.1. So if it is from 10,000 to 1000 to 1100, so it would be 0.1 only. Delta AOL by AOL, that would be 0.1. So what is the percentage change in this? What you need to calculate, this is, let's just say this is equation 1. What you need to calculate? You need to calculate delta ACL by ACL. Now we will apply simple mathematics here. What we are going to do? Now we are going to pick this formula again. On 1 plus AOL into beta. So I am going to do the partial differentiation on both of the side. So delta ACL divided by simply the differentiation of this 1 plus AOL beta whole square. 1 plus AOL beta would come as it is. Differentiation of AOL, that would be delta AOL minus AOL as it is, AOL as it is, differentiation of 1 plus AOL beta, differentiation of 1 plus AOL beta. So beta is a constant value. I am assuming beta to be a constant value, right? Because beta is defined by me only, so I am assuming beta is constant. Beta is constant. So what I was doing, AOL as it is and differentiation of this, so beta is constant, so differentiation of AOL would be delta AOL. So I hope you are understanding this differentiation. This is just the partial differentiation, simple mathematics. Delta ACL, that would be, now this and this portion would be cancelled, so it would be 1 upon 1 plus AOL beta whole square. Now you have the value of AOL beta because open loop gain is given. So from here also you can get to the final answer, but no, you cannot get to the final answer, because what you need to find? You need to find delta ACL by ACL. So what I will do, you need to find delta ACL by ACL. So what I can do now? Delta ACL by ACL. So I will just a second. Yeah, so one point I missed it. Here it should not be 1, it should be delta AOL. Now my target is to get delta ACL by ACL. So what I will do, I will divide by ACL on both of the side. So delta ACL by ACL would be delta AOL divided by 1 plus AOL beta square, and I am dividing it by ACL only. So what is ACL? ACL is AOL divided by 1 plus A beta. Did you understand this point? I divided by ACL on both of the side. Divided by ACL on both of the sides. So what is your ACL? What is your closed loop gain? That is open loop gain divided by 1 plus loop gain. Open loop gain divided by 1 plus loop gain. So what you are getting? Delta ACL by ACL, that would be equals to delta AOL by AOL divided by 1 plus A beta. Right. So percentage change in ACL, percentage change in closed loop gain would be equals to 1 by 1 plus A beta times of percentage change in open loop gain. What did I say? Percentage change in closed loop gain would be equals to 1 by 1 plus A beta times of percentage change in open loop gain. So what is the value of A beta? Given value of A beta. Given A beta equals to 99. So what will be the percentage change in closed loop gain? That would be percentage change in open loop gain. Percentage change in closed loop gain would be percentage change in open loop gain divided by 1 plus 99. That was 10% divided by 10. So in closed loop gain, only 0.1% change is there. Only 0.1%. Even if your A is not large, here we did not take any approximation. In this case, we took the approximation. In this case we took the approximation that your A is very large. So that's why we were getting nearly a constant gain, 1 plus R1 by R2. But here we are not taking any approximation. Even if we are not taking any approximation, and if there is 10% change in the open loop gain, you are getting only 0.1% in the closed loop gain. So let's just say your closed loop gain was 100. Let's just say your closed loop gain was, open loop gain was 100. This is your open loop gain. So it was changing by 10%. So you can get 1100 gain. Now let's just say your closed loop gain was 100 only. Now it will change by 0.1% only. So the gain you can get is 100.1 or 99.9. So which is very near to 100. But this is not very near to 100. At 1 millivolt it will give you 1 volt output, and at 1 millivolt this will give you 1.1 volt output. So that is a huge difference. But in this case, at 1 millivolt it will give you 0.1 output, and at 1 millivolt this will give you 0.1001 volt output. So which are, both are nearly the same only, right? The values are nearly the same. So here you are getting the gain stability. So this was the question. Also you can remember this formula as well. What is that formula? This is the formula that you can remember. The percentage change in closed loop gain will be 1 by 1 plus A beta times of percentage change in open loop gain. So this you can remember, this you can keep it in your mind, right? So this will be used in examination if they ask any 1 mark question from it. Well and good. Let's check what is the second thing that we can improve with the effect of feedback. That is, we can increase the bandwidth. What is the bandwidth? Do you remember what is bandwidth? We have studied it in frequency response. So let's just say this is your ideal gain A, but I told you the gain is not always constant. It depends on the frequency. So let's just assume our gain is of low pass filter. So what will be the body plot of this? What will be the body plot? The response is as low pass filter only. So this gives you a gain of A for omega naught frequency only, till omega naught frequency. After that the gain decreases. So this is what I told you when we were studying frequency response. Do you remember the frequency response? Coupling capacitor happens at low frequency. At low frequency they give the response as high pass filter. Parasitic capacitor takes place at high frequency. At high frequency they give the response as low pass filter. So we are just taking any example that this is our response, right? This is our response, frequency response. So this is our frequency response. So I can write V naught by j omega divided by V in j omega, magnitude of this with respect to omega. This is our frequency response, and here your V naught S is equals to A into 1 plus S by omega naught into V in S. Right. So here you are getting, in this range you are getting gain A. So you would want to run your amplifier in this range only. You would want your input frequency to be lesser than this. So there is very less range. What is the range for getting gain A? What is the range for getting a good gain? Here you are getting a good gain, that is gain A. But after that you will get a very less gain. Although this will not be A, this should be written in dB, because we are drawing the body plot. This should be written in dB. So basically in this range you are getting a good gain. So your bandwidth here is omega naught, getting a good gain. Now you need to increase the bandwidth for getting the good gain. That till this frequency I will get a good gain. So what you will do, you will connect it in negative feedback. So let's see how it is increasing your bandwidth. So this is the negative feedback. So what will be your V naught S by V in S? That would be A upon 1 plus A beta. So A upon 1 plus S by omega naught divided by 1 plus A beta 1 plus S by omega naught. So that would be A upon A beta plus 1 plus S by omega naught. Or what you can write, A omega naught divided by S plus omega naught into 1 plus A beta. Right? So what you are getting, this is the final answer. I have to keep it in the books only because I wrote it in one line. What is your 3 dB bandwidth now? Your 3 dB bandwidth has increased. Right? Your 3 dB bandwidth has increased. And previously our gain was written in this method, 1 plus S by omega naught. Right? A upon 1 plus S by omega naught. So I will write the gain in this manner only. So let's just take one more page. So here you are getting your V naught S by V in S. V naught S by V in S as A omega naught. Till this point I am getting A omega naught upon S plus omega naught to 1 plus A beta. Right? So let's write it in this manner only, because it will be easier to write DC gain. So I will take omega naught into 1 plus A beta is common. So it would be A upon 1 plus A beta divided by S upon omega naught into 1 plus A beta plus 1. This is your V naught S by V in S. What is the DC gain here? What is the DC gain? DC gain means put S equals to 0. What is the DC gain you are getting? A upon 1 plus A beta. And what is the bandwidth? What is the bandwidth? For bandwidth, what did I tell you? Put the denominator equals to 0. Put the denominator equals to 0. If you put this equals to 0, what is the bandwidth you are getting? Omega naught into 1 plus A beta. This is actually the location of pole, but since this is a low pass filter, the location of pole will be the 3 dB bandwidth, right? This is the location of pole, but since this is a low pass filter, so 3 dB bandwidth will be the location of pole only. If it was high pass filter, then what will be the 3 dB bandwidth? It would have been infinity. This concept we have seen in the frequency response, right? So how will the response look like? The response will look something like this. The gain is A by 1 plus A beta, and the frequency is increased to this. Previously what was happening? Previously the gain was this A. The gain was A, but the bandwidth was low. Bandwidth was low. Basically, previously this was the bandwidth. This was the bandwidth. This was the bandwidth. Now what is the bandwidth? Now this is the bandwidth. So your bandwidth has increased. This is your bandwidth. Previously what was the gain? A. That was A. And now what is the gain? Gain is A upon 1 plus A beta. But tell me one thing, this area and this area is remaining same. What do I mean? Gain into bandwidth. What is gain into bandwidth? That is A omega naught. A by 1 plus A beta into omega naught into 1 plus A beta. A beta will get cancelled. So gain into bandwidth, this area and then this area, gain into bandwidth. A divided by A into omega naught. So gain bandwidth product is constant. So this was the scene for open loop, and this is the scene for closed loop. So basically in the conclusion I can write for open loop DC gain was what? DC gain, you can put S equals to 0 here. What will be the DC gain? You will get A. Put S equals to 0 here, A you will get. So DC gain was A. And what was the bandwidth? Bandwidth was omega naught. For closed loop, what is the DC gain? DC gain is A upon 1 plus A beta. And what is the bandwidth? Bandwidth is omega naught into 1 plus A beta. In both cases, what is gain bandwidth product? I write it GBW, gain bandwidth product, that is equals to A omega naught only. So gain bandwidth product is always constant. So they can frame some question like this, that my DC gain is this and my 3 dB frequency is this. Let's just say they will write my DC gain is 10 and my 3 dB frequency is 2 Hertz, right? Now if I connect it in feedback, my gain becomes 1. What will be my 3 dB bandwidth? Tell me, what will be the answer? 20 Hertz, right? So gain is reduced by the factor of 10, so bandwidth will increase by the factor of 10. So gain bandwidth product is always constant. So these kind of questions are framed sometimes, right? So yeah, so here you have increased the bandwidth. So what is the advantage of increasing the bandwidth? That now your circuit will run till this frequency. In this range of frequency your circuit will run. So let's just assume your A beta is 99. So previously your circuit was running only for omega naught frequency. Now your circuit will run for 100 omega naught frequency. Let's just assume your omega naught is 1 radian. So previously you could only apply till the frequency 1 radian per second. Now you can apply your you can apply till 100 radian per second. That means it will run for high speed as well. 100 radian per second, that means your input is running at high speed. So now your amplifier is good for high speeds as well. So that's why sometimes you connect negative feedback so that you can run it on a larger frequency. So but what is the catch here? You are reducing the gain. In negative feedback, what is the biggest catch? The biggest catch is that your gain is reduced. So here your gain is again reduced, but if you need your amplifier to run at a higher frequency, then you will use a negative feedback. Well and good, everything is crystal clear. Let's see the last advantage now. That is the increase in linearity. So we will see it with an example only, very simple example it is. This is the op-amp. This is V0 versus Vin. Tell me how will the characteristics go? I will show plus V set and minus V set. So how will the characteristics go? If Vin is positive, what will happen? The output will increase to a certain voltage only. And if Vin is negative, your output will increase to a certain voltage only. Sorry, your output will decrease to a certain voltage only. After that, it will be saturated. Basically, your V negative is at 0. If Vin is negative, that means V negative is greater than V positive. Are you getting this point? Let's just say your Vin is minus 10. So what will be your output? Output will be A into minus 10 minus 0. So A will be some 10 to the power 3, let's just say. And this is your minus 10. Minus 10 millivolt you can say. This will be a small signal only. So minus 10 millivolts. So what will be your output? Minus 10. And let's just say your saturation voltage was 15. So your output will be minus 10. So it will be negative only. This is what I wanted to say. So if Vin is negative, then your output will be negative only. right? And it will go down, till a certain voltage only, till a certain voltage, and then it will be saturated. So this is plus V set and this is your minus V set, right? So now it is linear in this much region only, no? It is linear in this much region. After that it is saturated. So linearity is less here, right? Linearity is less. Linearity is less, right? So after feedback, what will happen? What is the gain? This is the same circuit that we have already used. This is the circuit that we have already seen. So what was the gain for this? V naught by V in. For negative feedback, what is the gain? A upon 1 plus A beta, which will nearly be equals to 1 by beta. So that would be nearly equals to 1 plus, basically in the feedback this time R2 resistance is there. Previously in the feedback R1 resistance was there. In the feedback there was R1 resistance. In the previous case R1 resistance. So answer was 1 plus R1 by R2. Now the answer would be 1 plus R2 by R1. Whatever the resistance that is there, you will be remembering it once you study op-amp, because this circuit will again and again, this circuit will be used again and again. So you will be able to remember it, but for now you can derive it as well if you are not able to remember. Because what is the feedback factor here? What is the feedback factor? This is your beta V naught. So what is the feedback factor? R1 upon R1 plus R2 into V naught. So beta value is, this is your beta value. This is the value of beta. Now 1 by beta would be 1 plus R2 by R1. So now since this is a constant gain, so if you plot V naught versus V in, V naught is equals to 1 plus R2 by R1 into V in. So now if you plot V naught versus V in, what happens? Because the gain is constant only, so it will always be following. So V naught will, it will always be this graph, it will always be linear. V in and V naught. And the slope will always be the same. If V in equals to 1 volt, what you will get? 1 plus R2 by R1 into 1 volt. If V in equals to 2 volt, what you will get? 1 plus R2 by R 1 plus R2 by R1 into 2 volt. If V in equals to 3 volt, what you will get? 1 plus R2 by R1, 1 plus R2 by R1 into 3 volt, right? So this is how it will go. So the linearity is increased, but it will be linear till the point of saturation, because it also cannot go above saturation voltage. But here this value is less. 1 plus R2 by R1 value will be less, but here the A value is very large. Here what was your V naught? V naught was AV in. So it will also keep on increasing, but the A value is very large. So for very less range of V in, it will be linear. Are you getting this point? Let's just say A value is 3 volt, 10 to the power 3. Okay, and your saturation voltage is 10 volt. So till 10 millivolt only, it will be rising linearly. Once it is reaching 11 millivolt, your output will be 11 volt, which is not acceptable. So it will be 10 volt. So this range will be achieved, right? So till 10 millivolt, you have achieved it. Now, in the next case, what will happen? Your gain will not be that large. It will be low. 1 plus R2 by R1, let's just say it is 5. 5. 1 plus R2 by R1 is 5. Now, what was your saturation voltage? Plus 10. So, how much voltage can you apply? Till 2 volt you can apply. If your V in is 2 volt, till 2 volt you can apply. In the previous case, you could apply only till 10 millivolt. Now, once you have reached V in equals to 2 volt, then your output will saturate. So the range has increased. So linearity is increased. Are you getting this point? So now there is a larger range of V in for which the circuit will be linear. Once it will go into saturation, it is certain that your circuit will go into saturation, but the range has increased. The V in range is increased. So linearity is increased here. So increased linearity. You can write increased linearity. So in the interview or in the written test, there is always a 1 mark question, that is, what is the effect of negative feedback? So what happens? Stabilize the system. Negative feedback stabilize the system. You get gain stability, your gain is stable, your gain is reduced by the factor of a upon 1 plus a beta. Your bandwidth is increased, your bandwidth is increased, and your linearity is also increased. So I will write it down. So in negative feedback, what happens? First thing, system stable, system stable. Second, gain reduces. Third, system stable means gain is stable. Basically, gain is stable. Gain is not depending on temperature, gain is constant. I should say gain is constant, and output will also not keep on increasing. If we increase it, it will go down. If we decrease it, it will go up. So there will be a stability, right? So gain reduces. What about bandwidth? Bandwidth increases. And what about linearity? It also increases. What about the time constant? Time constant. Tell me what happens to the time constant? Time constant will decrease. Why so? Because bandwidth is inversely proportional to time constant. If you have studied the network analysis, this very simple concept is there. Let's just assume this is your output. So this is your output or transfer function. This is your transfer function. So what is the bandwidth? Bandwidth is A. What will be the time constant? 1 by A. And if you take the time domain division of this, what you will write? E to the power minus 80. If e to the power minus 80 is there, so e to the power minus t by tau, this is the time constant. So 1 by tau is equals to A. So tau is equals to 1 by A. So bandwidth is always inversely proportional to time constant. If time constant is large, that means bandwidth will be low. If bandwidth is low, that means time constant is large. And what do you mean by low time constant? Low time constant means the circuit will reach its steady state very quickly. Time constant is low, that means the circuit will reach the steady state very quickly. And since the negative feedback system is stable, that means it will be at the steady state very quickly. It will gain the stability very quickly. So you can also tell that your time constant will be low. So time constant decreases. So this is what is happening in the negative feedback, right? So this thing you need to remember. So this is what we have studied about the feedback till now. What we started from? We started from the basics of op-amp because it will be used in our analysis furthermore. What we got to know, the new thing we got to know is that the op-amp output cannot keep on increasing. It will saturate at some point, and it cannot keep on decreasing. It will saturate at some negative point, right? So your op-amp output can be from minus Vset to plus Vset only. This is what we studied. Then we studied about the feedback. What is the feedback? Some portion of output is fed back to the input. It can be added as well, it can be subtracted as well, and based on that your output is changing. What about positive feedback? It is being added. In the positive feedback, if output is increasing, it will keep on increasing and system is unstable. What about negative feedback? If the output is increasing, the next moment it will decrease, the next moment it will increase. So system is stable, and in this case your output is being subtracted from the input side, right? So this was the negative feedback. So then we saw the example how to determine the type of feedback. Increase the output, work into the loop, eventually your output is getting decreased. So this is the negative feedback. If you increase the output, work into the loop, eventually your output is getting increased, that means it is the positive feedback. And one more thing, you have to nullify the input, right? Then we saw the effects. Gain stability, there is no stability in the gain in open loop, but when you make it in the closed loop, you are nearly getting a constant gain, that is 1 by beta, and beta is depending on you will make it constant only. We saw the example as well. There we were getting a constant gain of 1 by R1 plus R2, right? Then we saw what is the loop gain. Loop gain is A beta. Now after the conclusion, I will tell you how to find the loop gain, right? So then we saw the loop gain. Then we saw this example that your open loop gain is changing by some percentage. Then what will be the change in closed loop gain? So what did we find? The percentage change in closed loop gain would be 1 by 1 plus A beta into the percentage change in open loop gain. Percentage change in closed loop gain would be equals to 1 by 1 plus A beta into percentage change in open loop gain. This is what we studied. Then we studied the increase in bandwidth. The bandwidth increases, but the gain bandwidth product remains the constant in the negative feedback. And then we studied about the linearity. In linearity, if there is no feedback, the linearity is very less. For lower voltage of input, for lower input only, your output is saturated. But when you connect it in the feedback, for larger range of input, your output will saturate. So you have increased the linearity. Now we will find, so these are the points of negative feedback. The system is stable, the gain is decreasing, but the gain is stable as well. The bandwidth is increasing, the linearity is increasing, and the time constant is decreasing. Bandwidth increases means you have a larger band range, you have a larger frequency range where you can apply your input, right? Now this is your, what is your, now we are going to find what is, how do you find the loop gain. So I have already told you what is loop gain. So your open loop gain was A. After feedback, what will be your closed loop gain in negative feedback? That is A upon 1 plus A beta. So what you can write? You can write it as open loop gain. Just a second. Yeah, so you will write it open loop gain divided by 1 plus loop gain. And if there is positive feedback, what will be your closed loop gain? Closed loop gain would be open loop gain divided by 1 plus loop gain. Here also plus sign is there. Why is it so? Because loop gain for positive feedback is minus A beta. Loop gain for positive feedback is minus A beta. So always your closed loop gain is open loop gain divided by 1 plus loop gain. That's it. Your closed loop gain is always open loop gain divided by 1 plus loop gain. This is what you need to remember. That's it. Nothing else. Closed loop gain is equals to open loop gain divided by 1 plus loop gain. That's it. Now the loop gain is minus A beta in this case and loop gain is A beta in this case. How to determine the loop gain? So what you will do? Nullify the input. First thing is nullifying the input. Then you will break the loop. Here you can break the loop, here as well, here as well. Feedback loop you need to break. This is the forward path and this is the feedback path. So from the feedback path you need to break the loop from somewhere. You can break it here as well, you can break it here as well. So generally I break it after the feedback. After the feedback, here I break it. Here I break the loop. After the feedback factor, sorry. After the feedback factor I break the loop. Generally I break it here. Then I will apply two signal VF and V test. So VF I always apply near the, VF is always need to be applied near the feedback factor and V test always needs to be applied near the input supply. Near the input your V test will be applied and near the feedback your VF will be applied. So what will be your what will be your loop gain? Loop gain will be minus VF by V test. So this is the method. You are not going to understand anything by the method, but let's see it in the example. So for this particular configuration, find the loop gain. This is our question. So what I will do? First thing I will do is the short circuiting the input. Input is shorted. Then what I will do? I will break the loop. After breaking the loop, I will put this point as what? VF, because that is near to the feedback factor. So this is VF. And what this will be? This will be V test. V test. Now my target is to find VF by V test. Sorry, yeah, VF by V test. Always the, like, sometimes people get confused, sir, whether it would be V test by VF or VF by V test. What it should be? So which chapter we are studying? Feedback. So F will always be upper side and test will always be lower side, because you don't want to write test series. Do you want to write test series? You will say yes, but it is tough to write test series. So always test will be at the lower side and feedback will always be at the upper side, because this is our chapter's name. So VF by V test, this is how you can remember it. That's it. This is just a method to remember, nothing else. So VF by V test. So now what is happening? Input is gone. Input is gone. So this V test is going here. So the 0 minus V test. Here you will get minus V test, right? This is 0 minus V test. Now minus V test multiplied by A. So here what you will get? A into minus V test. So it will be minus A V test. Now minus A V test will be multiplied with beta. So what will be your VF? VF will be minus beta into A V test. A V test. So what will be your minus Vf by V test? Don't forget this negative sign. Minus Vf by V test would be A beta. So this is the feedback factor. Do the same for positive feedback. What will happen in case of positive feedback? This sign will be positive. So what you will get in case of positive feedback? You will get Vf equals to beta A into V test. So what will be Vf by V test? That will be A beta only, right? In case of positive feedback, positive feedback, this negative sign will not come. But your answer is Vf by V test, and then there is a negative sign. So answer would be minus A beta, right? So in case of negative feedback, your loop gain is minus A beta. Sorry, in case of positive feedback, your loop gain is minus A beta. But in case of negative feedback, your loop gain is A beta. So this is what you need to remember always. So what is the formula of gain for negative feedback? A upon 1 plus A beta. And what is the formula of gain for positive feedback? A upon 1 minus A beta. For both of the case, the formula is open loop gain divided by 1 plus loop gain. So loop gain for positive feedback is minus A beta. Loop gain for negative feedback is plus A beta. Everything is crystal clear, right? Let's take an example. So here again you need to find the loop gain. So I should have make it clear like this. Yeah. So this is the question where you need to find the loop gain. So this is the question given. You need to find the loop gain, right? So what I can do? I will solve it here only. This is the solution I am proceeding with. This is the answer. So what I will do, I will break the loop in between. Then near the feedback, this is the feedback. Near the feedback, I will take Vf. And then here I will take, near the input, I will take V test. And the next thing I am going to do is to short circuit the input. So V test is going here. This is 0. This is minus V test. 0 minus V test into A. So what this will be? Minus A into V test. So now this minus A into V test will be potentially divided. So minus A into V test, it will divide the potential in the scene of R1 by R1 plus R2. And that would be equals to Vf. So what will be my minus Vf by V test? This minus sign will go here, Vf by V test. So I can write minus Vf by V test. That is equals to loop gain. And that is equals to A into R1 by R1 plus R2. This was a very simple answer. So this is your loop gain. So sometimes in the examination they ask you find the loop gain of the particular circuit. So people always remember that loop gain is A beta. So they know the gain A, they know the forward gain A, they know the open loop gain. Then they write the feedback factor. What is the feedback factor? R1 by R1 plus R2. And then they say this is the correct answer. Yeah, here it is correct. But what if there was a positive feedback? What if there was a positive feedback involved? Then you will certainly forget this negative sign. I am pretty sure. You will certainly forget this negative sign. So never ever remember that your loop gain is A beta. No, your loop gain is A beta for negative feedback. This is what you need to remember. If you want to remember anything, then A beta is the loop gain for negative feedback and minus A beta is the loop gain for positive feedback. And if you don't want to remember anything, simply remember this method, that break the loop, Vf and V test will go around in the circuit and you will get the value of Vf, and your answer would be minus Vf by V test. You don't need to forget that minus sign. So minus Vf by V test, that will be your answer. You don't need to remember anything. For positive feedback, what is the feedback factor? For negative feedback, what is the feedback factor? This is just the simple method. And if you want to remember, for positive feedback, the feedback factor is minus A beta, and for negative feedback, the feedback factor is plus A beta. So that's it about the lecture. So this is the complete lecture where we studied about the feedback. So we studied about feedback amplifier. This is just the introduction. In the next lecture, what we are going to cover? In the next lecture, we are going to see the types of amplifier. This is going to be a very easy lecture. Next lecture will be very easy lecture. Voltage amplifier, trans resistance amplifier, trans conductance amplifier, current amplifier. What is the input resistance? What is the output resistance? So very easy lecture it will be. So in the next lecture, we will see all those kind of amplifiers. Okay then, thank you.